All right, welcome to Unit 2, Exploring Two-Variable Data. In this topic, we're going to look over 2.9, Analyzing Departures from Linearity. This is the last topic for Unit 2, and it's really going to focus on what happens when a point doesn't fit the pattern. So what are we going to explore in this topic? Well, we will explore 3 different ways a point can depart from the rest of the data, and we will explore what can happen if a scatter plot has a curve to it, but you still want to use a linear regression model. All right, so let's talk about different types of points that don't fit patterns. Now, you guys have known that a point that doesn't fit a pattern is called an outlier. So we're going to look at different points and how they are considered outliers. The first type of point we're going to look at is a point that is an outlier in both the x and the y directions. These types of points tend to extend the patterns and reinforce the pattern we do see. They actually will strengthen the correlation R because they fit the pattern. They will not significantly change the slope of the regression model, but they extend the line. So here is an example of this exact type of point that I'm talking about. You will notice that here is the bulk of my data right through the middle, and then I have this point right down here in the bottom right-hand corner that is an outlier in the x and the y direction. Its x value right here is far away from all the other x values, and its y value way down here is far away from all the other y values. But this is actually a good point because it extends the pattern. If here is my linear regression model, and then if I were to add that point, all that would help me do is extend my model. So a point like this fits the pattern. So if anything, it's going to increase the strength of R. So maybe without that dot down there, R is negative 0.85, but with that dot, because it's extending and strengthening the pattern, because again, it fits the pattern, now maybe I'm negative 0.90. Again, a stronger relationship. Remember, closer to -1, the stronger the correlation. And again, with or without this point, the slope's really not going to change at all. I mean, the line extends, but when I extend the line, the slope of the line doesn't really change much at all either. So points like this are good. Again, another example I could just quickly draw is if they're positive. Maybe here's all my dots, and then I have a new point like this. Well, again, that is a clear outlier in the x. It is a clear outlier in the x and the y direction, and a point like that does nothing more than extend your pattern. So it strengthens your correlation, and it doesn't really change much the slope at all. All right, the second type of outlier we're going to look at is an outlier in the y direction only. An outlier in regression is a point that does not follow the general trend shown in the rest of the data and has a large residual value when the least squares regression line is calculated. Now, outliers like this will weaken your correlation and also lower your R squared. Because remember, R squared tries to determine how tightly connected these two variables are. And when you have one point that is clearly not showing the right pattern, it is going to lower your R squared. Now, these points really don't affect the slope significantly. And to understand that, let's look at a picture. So here is, again, my data. And I now have this point right here. Now, remember, this is an outlier in the y direction only. Its y value over here does seem to be higher than everybody else's y, but its x value down here is actually not that weird at all. There are some points lower and some points higher in terms of x. So again, this is an outlier in the y direction only. Now, again, what we talk about is if I were to make that linear regression model, notice the large residual this point would have. So a point like this is going to have a large residual. Now, a point like this will weaken your correlation. So without that point, maybe I have a correlation of negative 0.85. And because I'm adding a point that clearly does not fit the pattern, I might weaken to, say, negative 0.8. Now, I'm not going to weaken all the way down to 0. My goodness, there's still tons of points that form a nice, strong pattern. But it does not fit, right? So it is going to weaken your correlation. And then the other thing to consider is with this point, the slope doesn't really change a whole lot. I mean, like I said, this linear regression line is trying to keep all the residuals as small as possible. It's trying to keep everybody happy. In throwing this one point in that does have a large residual, it's almost like the line just has to bear and grin it. Like it doesn't really have a choice. If it moves up here, well, then it's going to make everybody else below it unhappy. So it's not like the slope is going to make a major change just because of that one point. So a point like this definitely weakens your correlation because it doesn't fit the pattern. It may change your slope slightly, I mean just slightly, but it's really not going to change anything significantly that will hurt your linear regression model. All right, the third type of point that is definitely an outlier point is a point that is high leverage. Okay, this is an outlier point in the X direction, not the Y. So this point does have a lot of leverage, that's why we call it a high leverage point, to change a lot. All right, so let's look at this point. All right, so if here's my data right here, the same kind of data we've been looking at. All right, maybe this has a correlation of, positive, I would say positive 0.9, maybe even higher. I mean, it is pretty good strength. But a point that I'm talking about here is a point like this. This point right here is an outlier in the X direction, but its Y value over here is actually not that weird at all. There's points higher than lower than that Y. It's not an outlier in the Y direction. It's an outlier only in the X direction. These points do not fit the pattern. So again, adding that red dot will lower my correlation. It's going to weaken my correlation maybe to 0.85, something like that, okay? But what is most important about this point is that it is going to change the slope. Let me explain. If that point is not there, maybe there is my linear regression model. But if I add that point, now this point does have leverage. So this point could say, well, remember, what is a line trying to do, right? A line's trying to make everybody happy in terms of residuals. And with this current line of best fit, let me just kind of extend it all the way through. Notice it's going to have a huge, tremendous residual. Look how big this residual is. So your line of best fit might do something like this. Like it's going to say, well, you know what? I could teeter a little bit like this. And if I teeter a little bit like that, I'm still keeping all of these residuals inside of my data fairly low. I mean, all of these residuals in this general area are pretty small. And then again, but the advantage to changing is that now this is actually a pretty small residual, or at least fairly small, medium size. So the point I'm trying to make is that points that are outliers in the X direction only definitely do not fit your data. So adding them definitely weakens your correlation. But the most important thing is these types of high leverage points do change the slope. Because remember, a line of best fit, a linear regression model, is trying to keep everybody's residuals fairly small. And it's actually possible to adjust my slope and have everybody still somewhat happy. And that is actually a bad thing, right? We don't want our slope to change because of one point. But points like this will change your slope significantly. Now, we actually give these points a really big, powerful name. We call them influential points because they have the influence to change your regression model. So an influential point is a point that, if removed, will substantially change the relationship. So again, if removed or if added, whether you add it or remove it, it's going to substantially change your linear regression model. So the slope, the y-intercept, and the correlation are all going to significantly change when one of these points is added or removed. Let's go all the way back to the very first type of outlier we showed you. This is an outlier in the X and the Y direction. It's not going to change your slope. If anything, it extends your slope and it proves that your slope is true. So it's actually not going to change your slope or your y-intercept. Your line's going to change or going to stay, for the most part, completely unchanged. Then we talked about points like this that are outliers in the Y direction. Again, there are so many points that are making the line happy down here that adding that point or removing this point that's an outline in the Y direction isn't going to substantially change your line. It might change a smidgen, but not substantially. But an influential point, a point that's an outlier in the X direction only, these types of points are very powerful and do have the influence to change your slope. Let's take one more picture of one. Here is another picture of an influential point. Without that point, my linear regression model might be something like that, right? Pretty nice and easy to draw. But with that point, I do have the power to change my slope. Now, it's going to try to keep this residual a little bit smaller. Not going to still be small, but it's going to be better than it was if I use that red line. I mean, imagine the residual if I were to use that red line. Look how big that residual would be. So again, this point right here is an outlier in the X direction only, and points like this do have the ability to dramatically change your slope. So these are the points that you need to worry about. They actually appear to have smaller residuals because they're so influential. That's the whole point, right? Like this point influenced the line to move towards it, hence it looks like it has a smaller residual than it really should. And again, let me extend this red line. If I were to extend this red line, look how big that residual would be. But because that point was influential enough to move the line closer to it, it actually looks like it has a smaller residual. So those are the three different types of outliers we have. Outliers in the X and Y direction. Those are actually good. They extend the pattern. They strengthen your relationship. We have outliers in the Y direction only. Those weaken your correlation, but they really don't do anything to your line because they don't have leverage. And then the final point we talked about is a high leverage point, a point that is an outlier in the X direction that has a lot of leverage to significantly change your slope. All right, guys, hopefully you understand the three different types of outliers a graph can have and how removing them or adding them changes your relationship. All right, that's it for 2.9. Now we got to get ready for big tests over Unit 2 and putting all these pieces that we've been slowly learning together.